Hello, everybody. Welcome back to the Sustainability Podcast. My name is Gaven Simon, and I am joined today with Beth Mcdaniel. Beth, how are you doing today?
I'm doing great. Thanks so much for having me.
Of course. Thank you so much for joining us on the Sustainability Podcast. It's been such a pleasure just learning about the different organizations and companies out there, just doing interesting and engaging things, especially in the low carbon space. I'm really excited for this conversation. Can you get a little bit of background on Reactive Surfaces and how that company came about?
Yeah, it's helpful when we talk about the technology to give it context because what our day job is in a company called Reactive Surfaces. It's kind of like surface of a table, not services. I have to explain that a lot. But Reactive Surfaces, and what we are is we are an innovator in the paint and coating space. Most people haven't thought about paint and coatings ever unless they're in that business, but it's the biggest industry you never thought of. And what we do in that industry, like I said, we're not a manufacturer, we're an innovator in that space. And what we do typically, and what we've done for the last 20 years, is we take bio based molecules, things like enzymes, peptides, and we put those into paints and coatings to derive some sort of functionality on the surface. And I'm talking about after it's dried. So let's say we have an antimicrobial peptide. We put that is naturally occurring. They're all over you right now, and they're helping you every day. So they're non-toxic and natural. And we know how to harness that functionality from nature and put that and train that into a coating system like a paint. A paint is just a coating with color. A coating is used to cover, the substrates all around you. Okay. So everything that's manufactured has a coating on it at some point in its manufacturing process. Okay. We take advantage of that surface area to
Right.
try to functionalize it. So in the case of an antimicrobial peptide that we put into a coating system, after that paint or coating is put on a surface and dried, then it will have antimicrobial qualities so long as that paint exists on that surface. So you have an antimicrobial surface now. And that's our business, is putting functionality into paints and coatings to derive surfaces that have some sort of beneficial functionality to you
Right.
that react to people's environment. And we have different platform technologies that achieve that different functionalities.
And so is that newest technology the inclusion of lichen, and that's how lichen came about?
Well, okay, so that bears some explanation too. So over the last 20 years, we've developed these functional coding systems, and we do that as a business. And in light of the urgency and the disaster that is climate change that we're
Mhm.
all facing in this world, my husband, who is the inventor, I'm the business development person. So my husband is an inventor, and we have a team of scientists that are in the lab in Hattiesburg, Mississippi, that alongside a university called the University of Southern Mississippi, which has a very strong paint and polymer department. But
Okay.
anyway, I digress. But anyway, that's where we are. So imagine it's not just me and my husband in our garage.
Hmm.
But my husband did come up with the idea for a technology when we really got real about climate change, which was 2018 for us, was when that realization came and kicked us like a steel-toed boot in the head.
Hmm.
And, and so we decided, he said, I've been thinking about something, and it has to do with the way that lichen operate in nature. Now, we've all seen lichen. We hike through the forest, and I'm talking about the kind, well, specifically about the kind that you see like on a rock, real
Right.
brightly colored, very adheres real well to the surface. Really, you can't even get it off, right?
Hmm.
And we've seen them all the time when we go hiking. Well, lichen, they're kind of like paint. And that's what struck my husband because we were in the paint business. And
Hmm.
he saw a particular lichen, and it made him wonder, well, I wonder what functionality we could derive from that. So fast forward 10 years later, it's 2018, and he's thinking about climate change, and that all comes together. And he's like, I think we need to do this thing. And what lichen are is they're actually two different organisms that work together. They're an algae and a fungus.
Okay.
The algae captures carbon dioxide, just like algae do in nature. They, with the help of sunlight and water, they capture CO2 and convert that into glucose as food for the plant and release oxygen. Okay,
Mm-hmm.
so we wanted to harness that functionality. And the way that lichen do it in nature is the fungus actually provide like a welcome, warm environment for the algae to grow. And what I'm
Okay.
saying there is that it allows the lichen, I mean, it allows the algae to grow in a way that it doesn't outgrow itself. It gives it the right amount of gas exchange. It allows for sunlight, but not too much UV. So the fungus do a lot for the algae in this organism. And so in our system, we're always copying something out of nature. And so in this case, we were mimicking lichen in a
Yeah.
coating system. And so we put algae into the coating system and think of the coating system as like the fungus. Okay.
Mm-hmm.
We do all sorts of things with paints and coatings. That's what we do in our business. We know how to make them, for instance, block UV. We know how to make them reflect and refract light and things like that that could help that algae grow in a coating system. And
Mm-hmm.
so that is how we designed this to be a carbon removal paint system and surface system.
Right. So my next question was going to be, what problem are you solving in the industry? But I think I can maybe answer that a little bit. It just, you are reducing the amount of CO2 in the air by applying this coating to in on surfaces, and then aren't you able to like clean off the coating, so then you're able to just like keep reverting and like keep the cycle going and have the lichen, or like the lichen coating, continuously um, suck up carbon dioxide from the air, right?
Right. Well, okay. So just to get a little bit more specific, we've
Mm-hmm.
developed two different embodiments for this technology, and one of them is a coating that does
Okay.
that, and then another one is a surface system.
Right.
And in designing carbon removal systems, what you have to make sure of is that within the boundaries of the process itself, which is a very defined thing by what's called a life cycle analysis. Okay, so
Mm-hmm.
this is a third party that comes in and evaluates the technology, because you got to know what the biggest claim for carbon removal technology is that your your net is you're pulling down CO2. If
Mm-hmm.
you're in that boundary of your process, you're releasing more CO2 than you're pulling down. You're not what you say you are.
Right.
Okay. And so that is a very important distinction. And so everything, all kinds of carbon counting, including like all the materials and everything, that raw materials that went into your process, are all counted. And you have to make sure that all the energy and everything that it took to derive that, system is net negative, in that it's pulling down more CO2 than it's releasing in its process.
Mm-hmm.
And so that's one of the things that we've done. And there is definitely so when I mentioned the process
Mm-hmm.
includes, okay, so this is not, we have a coating system and we have a surface treatment.
Okay.
In both cases, these are not things that your audience is going to go put on their wall
Okay.
yet. And the reason why is it's not the highest and best use. Okay. We have
Mm.
such a big problem. What we need to do really is set up whole systems where we're maximizing the amount of surface area, thereby maximizing the
Okay.
amount of CO2 that it's working on. So
Mm-hmm.
we have derived like a modular system in which the most amount of surface area can be contained in there. We can monitor it. We know every molecule that's going in and out. And so once that CO2 is captured on the surface, then it's going to build up algal biomass. And when we build up, and we're watching it and monitoring it the whole time, and at the appropriate time that we've decided is the maximum, best, highest point of
Right.
harvesting, we harvest that algal biomass that
Mm-hmm.
contains the CO2. Then it goes through a whole process of drying, and then what's called pyrolyzing, which is burning. This is in an effort to sequester or durably remove that CO2 for at least 100 years.
Mm-hmm.
Okay, we want to make sure it's not just re-emitted.
Right.
And so in doing so, what we do is we dry that algal biomass and then we put it in what's called a pyrolyzer. And you probably know what one is, given your job.
That's when it's like you're burning something without the presence of oxygen, right?
Exactly.
Okay.
Exactly. It's kind of, and what the end result is like a charcoal briquette.
Yes.
Everyone knows what that looks like. It's black and
Mm-hmm.
it's just, and it's another way of carbon sequestration. It's just going to hold it there and without releasing it at least for 100 years. And that's kind of a well-known thing in the
Mm-hmm.
carbon removal industry is the use of biochar to do that sequestration. But the cool thing I'll add to that about that being the end of life for our carbon, as opposed to some other different methods of pulling down CO2, is that you can take that biochar, you can make it into like a sand kind of, and you can spread it all over soils. And
Okay.
what it does in nature is it absorbs water, and so it
Um,
actually helps soils become better and become better sinks. And so it's a very
mm-hmm.
carbon sink. So it's a very circular kind of process that way.
Beth, you hit the nail on the head. That was my next question was what is biochar and how can this biochar be of something of value? So that is currently the case study right now is having the biochar being created from the obviously the modular system creates it sucks up the CO2, then it's gone through the pyrolysis stage, and then it's turned into biochar. And then you're saying the next step in that process is somebody grinding up the biochar and turning it into a soil additive to help um, soak up more water, right? Is there
Right.
any
And that
more
would
uses
be,
for that biochar?
yeah, but that's not within, I guess it's not really within our boundaries. So we have
Okay.
this commodity that comes out of the process, and that
Mm-hmm.
commodity is a valuable commodity on the market. You can sell it for about, I don't know, we have in our um, estimates that I think it's like $300 to $600 a ton
Okay.
for biochar to sell it on the open market. And so there's a market for it,
Mm-hmm.
but that's not really where our business goes. But we
Right.
would end our carbon dioxide's life with that. That's where it
Mm-hmm.
ends. That's how it's sequestered.
Can you tell me how much CO2 is being sequestered? Like, what's like the amount of CO2 sequestered for like one modular system, 10 modular
Mm-hmm.
systems? How are you equating that?
Mm-hmm. Oh, that's a good question. So it depends on the technology, but what happened was we originally made the coatings technology where there was, excuse me, where we actually put algae in the coating system. Our next system is a surface area system where
Okay.
we have a novel substrate on which we're putting algae, and we're coating that surface as well. It's just a
Mm-hmm.
little bit of a different thing, but they had different impacts. And we estimate that, okay, imagine a 1 meter cubed module.
Okay.
Excuse me. Imagine a 1 meter cube module within which we can put right now. So the answer is kind of like what it is right now and what it will be.
Okay.
Okay. Because we're not engineers. So this thing has not been engineered to the nth degree. Okay.
Mm-hmm.
We've created a modular system that works, but we fully expect, some Brown and Root or someone like that to get a hold of it and engineer it to death.
Mm-hmm.
Um, but anyway, in our module, we have like 4 meters squared
Okay.
of surface area within that 1 meter cubed.
Okay.
And so, like I said, it will improve from there. But right now, it would be like 20, depending on certain other criteria, but let's say 20 to 40 of these 1 meter cube modules would
Mm-hmm.
pull down 1 ton of CO2 over a period of a year.
Okay, got it. 20 to 40 modular systems. Okay, got it.
So I have
Okay,
20 in my backyard right now, just to
right.
give you an idea. Like
And then
it's something that we fully expect to be used by everyone from individuals all the way up to large industrial facilities. And there's no reason why we couldn't be
mm-hmm.
this is a direct air system unless you want to pump it into the system. And then
Yeah,
algae loves CO2. So our system only improves if you just like even ramp it up a
right.
lot more. Like So it's a very
And
flexible system.
right. And you said that because the other like the so obviously the algae is taking the CO2 in this modular system, but that the coating has to be scraped ever so often. Didn't you say it was around like every 2 weeks or something? It has to be like cleaned or something.
Yeah, we call it harvesting because it's
Harvesting.
actually,
Harvesting is way
we're
better.
growing it and then we're harvesting it at the
Yes.
optimum point.
Okay. Perfect.
And yeah, we have a method for doing that within each one of the modules.
Mm-hmm.
And it's
Interesting.
harvested, and then there's some water that has to come out of it. You have to dry it out before it's pyrolyzed, and then it's
Got
pyrolyzed.
it.
And then it just starts the process over and over and over and over again.
Mm-hmm. So let's go back to the life cycle analysis or getting a life cycle
Mhm.
assessment. I'm kind of obsessed with LCAs, and in the next year, I plan on doing a study or doing some research with ARC on LCAs just because they're important, but they're becoming increasingly important in business operations. You see a lot of, I was speaking to a business last week, and they have been hiring a lot of LCA specialists to help them, like, basically equate how much carbon their processes and some products are contributing. And so I think
Mhm.
we're gonna continuously hear LCAs, and we're gonna hear about this. Can you explain a little bit about the process of your company subscribing to an LCA and requesting LCA, and how that process was, and what information did it reveal?
Yeah. Um, excuse me. So when you're seeking out an LCA
Mm-hmm.
to evaluate your technology, you want to find someone who's qualified in your area. Okay, so that, ours happens to be algae based, so we were
Okay.
looking for experts in algae that could evaluate this, and
Mm-hmm.
so we found expert, and we have several experts associated with different universities that are associated with this technology because we want it to be as rigorous, and it is very rigorous. We have some of the best algae experts in the world that are on our team, but also our LCA team is one of them.
Right.
And they are just so familiar with algae. So they're out of Colorado State. Their name's just Sustainability Sciences. And so what they do, I mean, they have to go through like every single detail of your process. They have to understand everything. So this is not
Yeah.
something that happens, I mean, it was off site, but we had many, 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 many meetings. I mean, we have a weekly lab meeting that these, people would join in on for months. Okay. To
Okay.
really understand what it is we're doing and the results that we're getting, because it's based on, your results. Now they can scale it up. They can take lab results and then scale that up. And in most
Mm-hmm.
cases, because of carbon removal technologies, it's such a nascent new world,
Right.
that's what everyone's having to do in this industry.
Mm-hmm.
Okay. And so we started our pilot plant. So we're a little bit more advanced than some technologies, and some are definitely, further in front of us. But um, so what they do in an LCA is outline your entire process, and that's your boundary. And everything
Mm-hmm.
that's included in the boundary is accounted for its carbon.
Okay.
Okay, that's the importance of the boundary. So what you're saying is if the boundary includes all of, the raw materials that go into your product, then everything that went into making those materials, all the energy, everything goes
Mm-hmm.
backwards, and they look at all of that, and all that carbon accounting goes into
Yeah.
your system.
Yep.
And certainly the energy is like that's the biggest barrier for moving forward for any of these companies, is that they're energy intensive processes, and ours can be too, but ours is solar. Also, we can use solar as our
Mm-hmm.
energy source, but a lot of them need more like geothermal or something like that. And that what that does is then it makes them have to be up alongside that geothermal energy.
Yeah.
Um, and it's not as what we say, location agnostic. Okay.
Mm-hmm.
Uh, well, anyway, so what you get is, I mean, just it is extremely detailed.
Yep.
What was included in the process. It's supposed to be based completely on real results, but they can be, like I said, smaller, in the lab results. And then they give you the net result is, how is it net negative or not
Okay.
as to CO2.
Got it.
But the other part of that you didn't ask about, but you probably are asking about, is another study, and it's called a techno-economic analysis,
Okay.
TEA. Yeah. And the TEA is the cost per ton that comes out of
Mm-hmm.
that of of that analysis. And the cost per ton is means everything, like all your capex costs, all your operating costs, your maintenance, all rolled to present value. And then they also include the carbon accounting. So it's this giant figure that comes down to just one number. And it's the basis for comparison of these technologies,
Yep.
because if you can, it has to be a net negative technology in the first place to even
Mm-hmm.
be in that zone, okay, to be compared. And then you compare the cost per ton, and that'll tell you something, okay? It'll tell you the cost at least. But all of those figures are included. Now, unfortunately, what's happened in the LCA world is not everyone has their boundary outlined the same way. And so
Okay.
if your boundary doesn't include the sequestration part, for instance,
Mm-hmm.
then you're not comparing apples to apples every time
Yeah.
you're doing a comparison. So just keep
That's
that in mind for
interesting.
your audience when you're thinking about
Mm-hmm.
that you have to take a look at what they were including in their boundary before you decide to compare it with another technology.
Mm-hmm. It was interesting. You kind of touched upon a little bit like the price per carbon, which is basically how um, price per carbon sequestered. That's basically like the number that people are judging a lot of these projects on. So last year, the Biden administration, obviously, there was an Inflation Reduction Act in the bipartisan infrastructure law that was passed in 2022.
Mm-hmm.
These two bills were sweeping bills, record number of dollars invested in the clean energy space, including the carbon capture space. The bipartisan infrastructure law that invested in pilot projects and like projects across mostly the southeastern United States are investing in carbon capture projects and direct air capture projects in Louisiana and Texas, I believe. But also, these laws are providing tax credits as the form of direct payments or a subsidy for a company or organization um, capturing carbon. And I believe one of the numbers out there was like I think it was like $185 per ton for direct air capture, and then the other one was like $80 for carbon sequestration. So there's these several tax credits, and it's all under the 45Q tax credit, which was
Mm-hmm.
extended by the Inflation Reduction Act. Will your customers be able to receive this tax credit if they deploy this technology on their property or facility sites? I would love to talk about the 45Q. I'm a little bit of a nerd on the 45Q, so really interesting
Yeah,
topic
we can
here.
go offline. I got a lot of opinions on the 45Q too, so we can carry on that conversation later too. But yeah, so 45Q, and I'm not an expert on it, but here's what I know. And definitely we intend it's in our sites, it's part of our business model. And there are two parts to it. One about that has to do with I think, okay, I haven't looked at it in a while, so
Yeah, it's
take it with
okay.
a grain of salt, but you might know better. But one part of it has to do with carbon capture in the
Mm-hmm.
form of enhanced oil recovery.
Right.
I think it's more geared towards that
Mm-hmm.
than and mitigation um, rather than direct air capture. But there's both
Yes.
of those parts,
Mm-hmm.
and fortunately, this technology could qualify for either one because, like I mentioned, we have these systems, these modular systems that certainly could be. You could pipe in that CO2, and then it's a carbon capture system, a mitigation technique
Right.
like you would use in an industrial setting, or they can be placed out in a field by themselves, and they'll do it with the
Mm-hmm.
sunlight. It'll just be um, it might happen a little bit slower because there's less CO2 in the ambient air than there is being pumped into
Right.
a system. But yes, we fully intend for these to be recognized by 45Q, and it would. apply 100. I thought it was $180
Okay. Yeah.
credit to the cost. Yeah.
Yeah. I mean that's a huge amount of money per ton. So I'm really hoping that you'll be successful in that
Thank you.
because I think that's just like a huge opportunity for a lot of companies in the space. Obviously, the more mature ones can take advantage of it, but so can the growing fields and the growing organizations in the space. So
Hmm.
really interesting stuff here. So, as I was poking through your website, doing my due diligence on my secondary research, I saw that you guys, Lichen, is in the running for the X Prize, which is a part of the. Is it a part of the Bezos Foundation, or did I switch
No,
it up? Is it a part of the? It's the Tesla Foundation, right? The
Elon Musk.
yes.
Yeah.
Sorry.
Well, okay. So yes and no. Okay.
Okay.
So here's the answer is that X Prize is an organization. There's a lot of different X Prizes, and
Okay.
it's a really cool thing. They're going on behind the scenes, but what they do, an X Prize generally is it's a call to innovation. It's to drive
Mm.
innovation in a certain area that's like a global existential thing. Clean
Mm-hmm.
water or food scarcity or things of that nature that are just big existential problems.
Mm-hmm.
And so what it is to a big prize that's sponsored to try to drive in new innovation in that space. And so there was a carbon removal X Prize that was started, I think it was 2021. We had already
Okay.
been working on this technology for a while. And it was a 4-year contest, which ends in April of 2025.
Okay.
And
Got it.
and so we are a contestant. And in order to win the contest, um, you have to demonstrate by that time that that you can capture and sequester 1,000 tons of CO2,
Got it.
ambient CO2. This is not in an industrial setting. It's so
Mm-hmm.
that the contest is just about carbon removal, and direct air capture is what they call it. And that it's $100 million contest. It's
Wow.
$100 million prize purse,
Mm-hmm.
biggest prize purse in history.
Yeah.
And so I think the first prize is like 50 million, then it goes down from there, like 30 and 20.
Got it.
And so we've been in that contest for ever since it started. We have our sights on the prize. It's not our business
Mm-hmm.
model, but it was a good way to grow up. It was a good way to grow
Mm-hmm.
up the technology. Gave us a lot of guidelines and moving
Yeah.
forward and how to get an LCA. And, it drove us to do these things in a timely manner.
Mm-hmm.
And so we have actually come out of the lab and we've built a pilot facility, and that facility is in Tracy, California, and that's where we'll be capturing that 1,000 tons.
Nice. Well, really looking forward to the April 2025 deadline, and I really hope you guys the best. And I
Thank
think
you.
it was interesting your comment about how that was like the largest prize announced, 100 million, and I think that correlates to the sizable opportunity and issue at hand. So I think that's a really amazing opportunity for all of the organizations involved. So let's talk about a little. Obviously, everything is not peachy keen, and everything doesn't happen in a vacuum. What are some of the challenges maybe facing your organizations or the carbon capture industry as a whole?
Well, some of the challenges that we faced is I think they're because it is such a new
Mm-hmm.
direct air capture is a new industry.
Mm-hmm.
There's the oil companies have been capturing CO2 for a long time because CO2, there's carbon capture in that way, because they push it back down underground. They haven't used direct air capture to capture it in the past.
Yeah.
They've usually like farmed it from the earth. They got CO2, and then they push it down into a well to push the oil out.
Mm-hmm.
And so um, one of the problems is that we're often compared with that. Okay.
Okay.
And so that's not a net negative process if at the end of that you've got oil that
Mm-hmm.
is going to emit. Now, if you define your boundary to not include that, then
Right.
you might have an LCA TEA that looks like it's a whole lot better than some other technologies. But the
Mm-hmm.
problem is with enhanced oil recovery, if you include the oil in your
Right.
boundary, then you're not net negative anymore. So
Mm-hmm.
that's not a net negative. It's better to produce oil that way. Okay, that's a
Mm-hmm.
more sustainable way. But my point is that the comparisons are a little bit unfair sometimes because it's a
Yeah.
nascent field that there's not a lot of standards that everyone is abiding by. Everyone's kind of
Yeah.
feels like they're doing their own thing, and
Mm-hmm.
so we're trying to establish standards, even in the commodities market. So, there's a carbon offset market where these things are traded. If one,
Mm-hmm.
if you can pull down a ton of CO2, then you can go trade that on the market and
Right.
to someone else who needs to emit a ton of CO2. That's
Mm-hmm.
worth something to someone. And so that's what's traded. And they found out recently, for instance, that there was a report that came out that up to 90% of those carbon offsets that are being traded on the market are not in one way or another doing the job. Okay. They're
Mm-hmm.
either double counting, there's fraud, or they're not what's called additional, meaning that um, if you have trees in your backyard, okay, and they're
Mm-hmm.
pulling down a certain amount of CO2, and you just go claim that as your carbon removal system and get an off and sell an offset based on that, well, you're going to have
Yeah.
those trees anyway. Like you didn't
Yeah.
add anything to the mix. Okay. So that's
Right.
what additionality means. So there's a
Yes.
lot of different factors that, some of these systems, it's great to have trees in your backyard, but you don't necessarily get to claim it because it's not anything extra.
Right.
Um,
It's like that
well,
base load,
anyway,
like the base
yeah. And the
load. Like,
problem with it, yeah, with anything like any kind of fraud in the system, like double counting. What happens sometimes is the person who, builds a system on someone's land counts that carbon, that CO2 removal as well as the landowner. Okay,
right.
and so that's double counting. But the problem with any kind of fraud in this system is that if anything is being um, if the CO2 is not really being pulled down, then someone else is emitting based on that.
Yeah.
And so it's not a net zero thing. All of a sudden, it becomes you're putting out more CO2 because of this faulty system. So we can't
Mm-hmm.
have that. We've got to clean up that system.
Right.
Okay. And so,
Would you
and people
say
have
that? Sorry. Would you say so? Your comments about the carbon market. Would you say that Lichen will not be a part of the carbon market, or you're just have that's your viewpoint on the current carbon
oh
market?
no, we're going to be a part of the carbon market, but
Okay.
the carbon market needs to clean up a little bit.
Right. And I think that's going to
Hey,
be
mm-hmm.
Oh, sorry. I think that's just going to be through continued like regulatory moderation and policy creation around the carbon market and
Yeah.
like kind of like setting those boundaries and setting those it's escaping me right now, but just like kind of setting the rule book of the carbon market because kind of right
Right.
now it's
And
like a
that's
free
what we're
range.
missing.
Yeah.
Yeah, we're kind of missing that.
So, is there any other comments that you would like to make about Lichen? Do you have any other maybe suggestions for organizations receiving an LCA in the future? Any last words that you'd like to share on this episode? I really appreciate your time today.
Thank you for having me. I appreciate your time too. Um, yeah, I mean, just remember there are things that you can do on an individual level. If you're just listening to this and you're like, okay, well, I didn't invent carbon capture coatings. Okay, what can I
Hmm.
do? It's important that carbon removal systems are promoted. They are an integral part recognized by the International Panel on Climate Change of the UN. They're an integral part of the overall formula. We've got to promote carbon removal technologies, or we can't achieve the milestones that we need to.
I really
Mhm.
appreciate this conversation. I really look forward to seeing all of your success, and I just want to say thank you so much, Beth.
Thank you, Gavin. I really appreciate your time too.